Okay, so this is lesson 3.06, solving polynomial equations. And it's not very difficult. What's difficult is going to be the algebra 2 factoring that's involved in order to solve equations. So example 1 actually is problem 4 from tonight's worksheet. So does that mean you don't have to do problem 4? No, you still should do it. It's a good repeat. But I thought this problem was exemplary of the problem set. So I was like, I'll just use that one. Okay. So let's take a look here. So in order to do this, one, you want to make sure the equation is equal to 0. Okay. So the first thing we're going to do is set equation equal to 0. So, and this one is, and then I'm going to look to see, well, is there a method that I know to factor? So I see that we have 4 terms. Do you guys agree that it has 4 terms? 4 terms always tells me to try to do factor by grouping. So when I am going to do factor by grouping, I know that this sign in this location here, this very middle sign, I want this to be addition. So just as a review. So I'm going to write this as x cubed plus 5x squared. And then I'm going to change this to adding a negative to x, subtract 10 equal to 0. Do you all agree it's the same? Okay, now, just to preserve this in our notes, I'm going to write it one more time before I write on it. If you forget which one you want positive, you can change them all to positives, right? Or adding. And so now I'm going to do the grouping where I'll group the first two and the last two. Oh, I forgot to say equals 0. Okay, I'm going to look for a GCF in the first group. What's the GCF in that first group, in this one right here? Yeah, you can see they both have x's, in fact, x squared. So I'm going to take an x squared out. So x cubed divided by x squared is x. 5x squared divided by x squared is 5 plus, okay, and then what's the GCF in the second group? Good job. Okay, so I see the leading negative here. So you always factor that out, and it is going to be 2. And so that leaves me with, let's see, negative 2x divided by negative 2 is x, minus 10 divided by negative 2 is plus 5, equal to 0. Okay, how are we doing there? We okay? Okay, so now, do you guys see that we have 2 terms that we're adding together here? I'll underline them here. It's this one here plus this one here. Do you see that we're adding those 2 terms together? So, and then notice that they both have a common factor. See here how they both have the x plus 5? So what I want to do is I want to factor out the x plus 5. So it's a GCF. So when I divide the first term by x plus 5, that'll become a 1. And the second term, that becomes a 1. So notice I'm left with x squared times 1, which is x squared. And then when I divide the second term by the x plus 5, I'm left with plus a negative 2 or minus 2 equal to 0. So I've done my factor by grouping. Now I have two things multiplied together to give me 0, so either the x plus 5 has to equal 0, which tells me x is negative 5, or the x squared minus 2 has to equal 0. Now, does that factor further? No, it doesn't, does it? So what I'm going to do is I'm going to solve it by square roots because there's only one x squared and there's no other x's. So I'll add the 2 to both sides. So I get x squared is equal to 2. Okay, and then I want to get rid of the square. So I'm going to square root both sides. So when I square root the x squared, remember that's going to put the absolute value of x because we have to make sure it's going to be positive. I can't do anything with the square root of 2. So take the absolute values off and we get x is the plus or minus of the square root of 2. So to solve, if I list the zeros, right, the list of zeros, would be the negative 5, the minus root 2, and the plus root 2. Excuse me. Let's highlight that as the answer. We could also write this as a list of x-intercepts. You could also you could leave it just as it is, right? Say the x-intercepts are negative 5, negative root 2, and root 2. You could write plus or minus root 2. I'm okay with that. But if I want to write the list of x-intercepts, I could also write it as xy pairs. Right, where the negative 5, whoops, let's fix that, right, would be negative 5 and then comma 0, right, because you go over negative 5, up 0. Okay, and then the same thing for this one here. It would be negative root 2 comma 0. Okay, and then finally root 2 comma 0. Now, usually if we're finding the x-intercepts, we're actually trying to graph. So you wouldn't leave the radicals, you would give me decimal approximations because you're going to actually put those physically on the graph. You would use a calculator to come up with those. Okay, any questions about example 1? Okay. I see a few people still finishing copying the notes down, so I'll give a minute. We will go to example 2, which is problem 6 from today's worksheet, it looks like. Are we done copying now? Okay, example 2. Okay, so now this one. So on this one, I'm seeing some important things. Okay, so it says to solve. So the first thing I want to do is set it equal to 0, right? Is it already set equal to 0? So it done, check, already set equal to 0. So now I'm looking at it. I see 3 terms. It makes me think a trinomial, but the highest power is 4. Usually with trinomials, the highest power is 2, right, in algebra 1. But now we're in algebra 2, and we could see if it's in quadratic form. To see if it's in quadratic form, we want to see, does it have 3 terms? 1, 2, 3. It has 3 terms, remember. Here, right? So trinomial. So check. Okay. Does it have a constant? Remember? Check. It does. Okay. And then, right, the uh, is the first exponent double the second? Right? We don't need the word is, do we? So let's get rid of that from my notes. We don't need that. We just say that it is. Does it fulfill that? So if I look at this exponent here and I double it, do you get the first one? And the answer is yes. So therefore, right, this can be rewritten in quadratic form. So that means that I can rewrite that first term, x to the fourth, as an x squared, right? The middle term, which is what our goal is. So I'll rewrite it as x squared, and then the doubling, right? Squared. And then minus 12 times x squared, right? That is the same thing, plus 32 is equal to 0. Do you all agree that line is the same as the line above it? Yeah? Lots of head nodding. Okay, so then we have here, let's let a be equal to the x squared. So this becomes a squared minus 12a plus 32 equal to 0. Now, this has a leading 1 here, doesn't it? A leading 1 in this location. Are you guys okay with that? So we're going to just try and factor this into our two groups. Right? We know a times a is a squared. So now we're going to look for what are factors that multiply to 32 that add to be negative 12. Well, in order to get the positive here, right, and this is a minus, then these both have to be minus because a negative times a negative is a positive. Is there two numbers that multiply to 32 that add to 12? Negative 12 specifically? Good. 8 and 4. So negative 8 and negative 4 specifically. Okay, and then I can put this back in, and I'm going to put the fact that the a is x squared and then subtract 8 here, and then change this to x squared, subtract 4 equal to 0. I know some of you are all like, okay, Labus, I really do appreciate that substitution technique that you have in light green on the screen, but I can actually go from the original problem here at the top and go straight to there without needing the substitution technique. Do I have to use it? And the answer is no. You don't have to use it. It's a technique that's meant to be like a crutch, right? You use crutches until you don't need them anymore, right? Until you're strong enough without them. And so then if you are at that point where you already don't need it, then fine, you don't have to use it. But if you still need it, then use it. No big deal. Okay, now we are in Algebra 2, so we have to ask, can we factor further? Do either of those factor again? And I think most of you look at the x squared minus 4 and go, yes. The x squared minus 8, you're all like, but it doesn't factor again, not nicely according to what our skills. And so I will leave this here, x squared minus 8. But I know that second one is the difference of squares, right? This is x times x. This is 2 times 2. So I know one group is plus, one group is minus. X is in the front, 2's in the back. Now I asked if I could factor further again. I can't. So now I'll set my factors here equal to 0. So x squared minus 8 equal to 0. X plus 2 equal to 0. X minus 2 equal to 0, right? Because I had three things that were multiplied together here that equaled 0. So one of them, if not two of them, if not all three, have to be 0. So we'll set the factors equal to 0. And so you can see for this last one, right, x is 2. For the second one, x is negative 2. Okay, and then for the first one, we have to do a little bit of work. I can add the 8 to both sides, so that gives me x squared is equal to 8. Then I can get rid of the square by square rooting. That's going to give me the absolute value of x is equal to the square root of 8. Isn't that 4 times 2? To get rid of the absolute values, put plus minus on the other side. The square root of 4 is 2, and then we'll leave the other square root 2 there. Okay, so now I can list all zeros. And that would be the negative 2, 2, the negative 2 root 2, and the positive 2 root 2. Okay. Oh, not the highlighter. So also okay is if you write plus or minus 2, plus or minus 2 root 2. And I'm okay if we summarize like that. The list of the x-intercepts. Would be negative 2, 0, 2, 0, negative 2 root 2, comma 0. And we could, if we're graphing that, we'd actually get the calculator out, right, and come up with the decimal approximation. And then here, right, would be 2 root 2, comma 0. And that would be that. Okay. Okay, and then finally, just as a note, okay, I focused on two kinds of factoring, right? Initially, factor by grouping and quadratic form. Notice we did have some difference of squares also that we did, but we could use any form of factoring. So let's put this into our notes. Any factoring technique we learned can be used to solve polynomials. Can be used to solve polynomials. So keep that in mind as you guys are doing your homework. And with that,